Continuing with 4.3, I had to refill this section maybe 3 times because I just completely butchered it all of the other times. But this time I really got it down. And I'll actually pinpoint where I fell short along the way. This first part's not too difficult because it's similar to what we saw in the first part where we have these 3 points seen here. We're trying to make a standard form equation of the graph where we have an A coefficient, a B coefficient, and C, which again is our y-intercept in disguise. So we know that we have these 3 points with these select qualities, which if we look at the first point, this is saying that if x is 0, plugged in here and here, the outcome has to be 0. If we plug in where x is 1, here and here, the outcome has to be equal to -2. We also see if x is -1, the outcome has to be -4. So we have a lot of information that's given to us. We can probably say a decent amount already because if we look closely, since x is 0, this means that we have a y-intercept. You might have noticed that my laptop just went on low battery. Don't cry. We're good. We got this. I just listened to the Carter 5 and that's the one song that got stuck in my head, so don't cry. We got this. As we've seen previously, we can work with equations that have 3 terms in them. So if we take this further, we can actually build eventually a system of equations where we can simplify a times 0 squared, so pretty much 0 plus c equals 0. So this is saying that c equals 0, which is good. We already kind of acknowledged that. So this actually makes our life easy because we already know one of the answers, or one of the terms. We also know if we simplify this, 1 squared is 1. So a times 1 is just a. Adding on b times 1 is just b. C is 0, so I'm not even going to write that. And this all should equal -2. If we simplify this last equation, -1 squared is just 1. So this should be just 1a. We're then deducting b, and this should be equal to -4. This should look like a system of equations at this point where we only have 2 variables to solve for. We're also lucky because b has an opposite. So when we combine from here, a and a gets us 2a, b cancels, -2 minus 4 gets us -6. A is definitely going to have to be equal to -3. And so notice, just like the alphabet, we have A, we have C, but no B. So now our goal is to solve for B. And you have a few options of how you can go about this. Pick your poison, pick either of these equations. You know what A is, so just plug accordingly. Excuse me, and solve for B. So if A equals -3, and we added on B, based off of this equation here, this should be equal to -2. So pretty much -3 plus b equals -2. If I add 3 to both sides, b in this case is going to have to be 1. Which is totally fair game to use this equation seen here. I could have picked this equation and that would have worked just fine. But this is going to say that our b term's 1. So when we combine all of our terms seen here, the standard form equation should be -3x squared plus bx, in this case plus 1x plus 0. If you really want to make one of your math teachers happy, whether it's me or someone else, get rid of that 0. You don't need it. And just leave -3x squared plus x. And that looks awful, so I'm actually going to rewrite it again. -3x squared plus x. Wonderful stuff. As we see here, building into systems of equations, that's really important.